Welcome to Energy Talks, a regular podcast series featuring expert discussions on power system testing, data management, cybersecurity, and important trends in the power industry. My name is Scott Williams from the podcast team at Omicron, and I will be your host. Hello, everyone. In recent episodes of Energy Talks, we have highlighted how the ongoing development of innovative power system and protection testing technology ensures that users are able to achieve their current and future requirements for assessing the condition of their electrical power assets, while making testing easier at the same time. This also applies to testing devices for the measurement and analysis of partial discharge, also known as PD. In this episode of Energy Talks, I speak with Burkhard Daniel, who is the lead developer of the MPD Suite PD measurement and analysis software used with Omicron's MPD PD testing technology. I will ask him to describe the evolving history of PD testing and how ongoing software development and innovation have made PD measurement and analysis more accessible and easier for users over the past 2 decades. I will also ask Burkhard to elaborate on how MPD Suite software helps users of MPD testing devices remain up to date with current and future trends in PD testing, including updates to international standards like the IEC 6270 standard for PD measurement. So without further delay, welcome, Burkhard, to this episode of Energy Talks.
It's my pleasure to be here, Scott. Thank you for having me, and I'm excited to talk about PD and in particular the MPD product range.
Burkhard, could you please tell us how you are involved with partial discharge measurement technology and what has been your focus?
Yeah, certainly. I have been working on the MPD product range since 2002, starting with the MPD 402, which was a very specific niche product that's no longer even being produced. But I have been working on the MPD products since then, and most recently on the MPD 800 and the MPD Suite. These days, I am leading the software development of the MPD Suite and am acting as the product owner.
Okay, very good. Could you briefly describe what is MPD technology?
The MPD technology is a set of products that do partial discharge measurement and analysis. They're basically devices that are used to measure partial discharges in high voltage assets and do analysis and visualization of the results so that users can get a better idea about the insulation health of their assets.
Very good. So you were involved with MPD technology at the beginning with a company called Mtronics.
That is correct.
And then the technology moved into the Omicron product range.
That's right, yes. Mtronics was founded in 1997. In 2006, we joined Omicron and became part of the Omicron family.
Burkhard, why is partial discharge testing important to perform on electrical equipment?
Well, partial discharges are a phenomenon that happen inside of the insulation of high voltage assets, and they can tell you something about the health of the insulation systems of those assets. Because when those partial discharges happen, there are little localized electrical discharges in the insulations. They can degrade the insulation and they can cause the high voltage asset to fail or certainly need maintenance down the road. So having a clear view of how much PD is in your asset is a good idea to be able to know when to plan maintenance for a high voltage asset.
What is a partial discharge test and how does it work?
A partial discharge test is basically a high voltage test where you subject your asset to high voltage under controlled conditions. This could be either an online test or an offline test. Online means that your high voltage asset is connected to the grid, and offline means you have a separate high voltage source and you test the asset in isolation. When you do apply the high voltage to your asset, you then measure these little partial discharges that happen inside of the insulation.
Burkhard, what are the essential components then used for partial discharge testing?
Well, you certainly need your asset, obviously, that you want to test. So you need a high voltage source, which can be the grid in an online test. And you need a way to decouple the partial discharge from the asset into your measurement device. Typically, you use a coupling capacitor for that or an HFCT, a high-frequency current transformer, in what we call classical PD measurements. But there's also other ways to do this, for example, using UHF antenna and UHF measurements, or even optical or acoustic measurements.
Burkhard, partial discharge testing has evolved and continues to evolve. What have been the key milestones of this evolution, both in hardware and software?
Initially, when people wanted to know about the insulation quality of their assets, they used something that's called RIV measurements, which is basically radio interference voltage. So they were basically just walking around their asset with an AM radio in their hand and listening for noise inside of the radio, which would be caused by little discharges inside of the asset. That's how it all started. And that's actually still being used today, RIV measurements. But then the next level was using oscilloscopes to basically look at these little discharges as signals on the screen. And then you had dedicated PD measurement devices that were based on oscilloscopes. But then in the early 2000s, there was that big leap when these devices became digital and much smaller. So for example, the MPD 540, when we introduced it in 2004, that was a really small device that used mobile phone technology, basically. And we've evolved that with the MPD 600 in 2006 and the MPD 800 in 2020. One thing that new digital devices brought to the table was multi-channel measurements, where you could measure simultaneously in different places, which enabled a lot of new analysis methods. And just generally using digital technology and software-based approaches gave you much better analysis tools, much better signal processing quality, more ways to suppress disturbances and noise, and made it much easier to generate reports and measurement results that are standardized, neat-looking, and can be archived. We also developed some very specific technologies that are used for suppression of noise and disturbances, such as three-part and three-frac. And we also spent a lot of time looking at PD fault localization technologies using reflectometry and time-of-flight measurements. And all of these together are very useful for PD measurements.
Interesting. So exactly what role does software play in partial discharge testing, and what essential functions does it perform, and how do they assist users?
Yeah, software is ever more important in this field because essentially you can iterate much faster with software than you can with hardware. So having most of the functionality in software allows you to add features even to an existing product, and we've done that in the past. Software is just a lot better at doing certain things. For example, signal processing is mostly handled in software, so you can add new algorithms to deal with different types of signals, to deal with noise suppression in a different way. You can also take the signal that is recorded by the device and store it for later use, which is also very useful. And basically, the core functionality of the software is to take that signal from the device and then derive some key measurement quantities from that, also produce some visualizations that users can look at, create reports of the measurement, store the data for later perusal. So, and of course, do things like noise suppression and disturbance removal.
Burkhard, you mentioned a few points. Specifically, how has software used in partial discharge testing evolved to enable greater ease of use, safety, and efficiency?
Yeah. Computers have become more capable over the years and have allowed us to do even more intensive signal processing and get better accuracy, get nicer looking, better resolution visualizations, get faster ways to report, and basically have a better way to reproduce these measurements over time. And also using desktop and laptop computers, which people are familiar with, makes it both easy to use something that you already know, and at the same time, using those to connect to the measurement device using a fiber optical connection makes it a lot safer to operate the device, because you don't have to be in the high voltage area. You can be somewhere where it's safe to be during the measurement. And advances in user interfaces, both in computers themselves as well as in software, are applied to PD measurement devices, and we've done that too. So for example, there's now guided workflows and new types of visualizations that people didn't think of before. We have the ability to customize user interface elements in the software to adjust the experience for each user based on their skills and needs. And those are things that software allows you to do that are much harder to do with a hardware device.
Now, we've talked about evolution. What about now? What new software innovations have been recently introduced to optimize PD testing and user experience?
I've already mentioned guided workflows, which is something that we have looked at and that we continue looking into. For example, we have a guided workflow for cable factory testing, which is geared particularly towards that use case, testing of power cables in the factory for quality control. And we plan doing more of these workflows. And what the innovation here is that it makes it actually easier for people to use PD measurements, even if they don't know too much about it, because they don't have to know everything about PD measurements. They just have to know how to perform a cable factory test. And they get the tools and the features needed for that particular task, and they only get to see them when it makes sense to use them. So it just makes it much easier to actually employ the full power of the MPD technology for that particular use case. What we've also done is implement performance check wizards to help with fulfilling some requirements from the relevant standards and to do self-tests on the device to make sure that your device works correctly before you perform a test. We've also enhanced the use of multi-channel measurements by allowing several different measurement channels to trigger one another, which helps with things like fault localization and cables, or even just with looking at the PD signal in a time domain from different places, which can help with determining what type of PD you're looking at. And of course, I also mentioned things like technologies to suppress noises, such as 3-part and 3-frag we've pioneered, which allow you to selectively look at certain PD sources and ignoring anything that you don't really want to see, disturbances and noise. And one thing that we also have done to make it easier to use PD measurement in software is we've added user profiles to the software, which allow you to customize the user interface in such a way that you only see the things that are relevant for you, for your specific use case. And you have a lot of freedom in doing so. You can customize user interface elements, you can limit certain values that can be set, and that just makes it easier to provide something that fits your use case.
And it also makes testing faster, more efficient.
It does, yes.
When we talk about PD testing, we talk about standards, and specifically the IEC 6270 standard for partial discharge testing. Why is this standard important? And could you describe how this standard has guided development of PD testing technology?
Sure. The IEC 6270 standard is a foundational standard. It basically defines the general approach to how you do PD measurements. It specifies requirements on devices that you can use in that endeavor, and it lays out the measurement setup and the parameters that you can use for a PD test. On top of that, it also describes things like how you calibrate your test setup and is applicable to all high voltage assets. This is always going to be mentioned when you do standards compliant PD measurement. There are additional standards that referenced the IEC 6270 standard, and they are asset specific, but IEC 6270 lays out the foundation. It has evolved over time to cover technical progress because initially it was focused on analog devices, and only in the 2000 edition did it first mention digital devices.
Okay. So with this standard, there have been recent updates, I understand, in 2025, this past year. What are these updates and how are they reflected in your current development of MPD technology?
The standard has updated to add more guidance on non-classical measurements, specifically things like DC and UHF measurements, for example. It also increased the frequency range of where you can do standards compliant PD measurements up to 500 hertz. But the most important changes are probably that it changed the way performance checks are to be done, made it easier and more accessible to users. And we have actually implemented that change in such a way that we now offer a performance check wizard in the upcoming 160 version of the MPD suite that follows the new and revised 2025 version of the standard. And one other thing that the standard changed was it clarified the specification of the most important reading, which is the largest repeatedly occurring PD magnitude. And it specified how those values are to be computed for repetition rates that are below 1 hertz. And we've also implemented that change into the MPD suite.
Could you describe what you mean by performance check and why is that important?
So the standard defines that a measurement device has to undergo a performance check every year. And the reason for that is to ensure that the device itself remains functional, that it continues to measure accurately in a standards compliant way. And the new standard does that by requiring the PD measurement device to show that its linearity is still within the prescribed limits, so that measuring low values and high values gives correct values in both cases. The previous version of the standard looked at the PD filter itself and asked users to verify that the filter response remains stable. However, with digital devices, that is no longer a problem because digital devices don't age like analog devices do. And in recognition of this, the standard has actually changed the performance check to be something that's more relevant.
Burkhard, what do you see as coming trends in partial discharge testing, and how are you able to keep up with these trends and provide users with the PD testing capabilities they need?
Yeah, so important changes in PD measurements stem from changes in the high voltage infrastructure that's being used. For example, there's a lot of power electronics these days in high voltage grids. Power electronics can stress the insulation in different ways. There's inverters and there's thyristors being used to switch high voltage grids and make it more difficult to do PD tests in certain ways because they add more disturbances and noises, but they also stress the insulation. PD testing will have to take that into account. There's something called PD under impulse testing, which is a research topic where a lot of people are looking at how that should be done, and that is something that we're following closely. And where we also have made some changes in the software to allow for that. Then another big topic is DC measurements, because there will be ever more DC cables that are being used now these days for offshore installations or to connect different grids or different subgrids together. And PD measurements under DC is also an ongoing research topic, because normally when you do PD measurements under AC conditions, you use a tool called PRPD, which is a phase-resolved PD pattern visualization. And you don't have that in DC because you don't have an AC phase to resolve this. So there's different ways you can measure PD in DC situations. Also, the types of signals you see look different in DC than in AC scenarios. Yet another topic that is coming up more and more is VLF measurements. VLF stands for very low frequency, and is basically the approach that you use a very low frequency to energize, for example, like a medium voltage cable, because you don't need bulky, large equipment to do that. And then you measure PD using these frequencies that are not 50 or 60 hertz, but much lower, maybe 1.1 hertz or even 0.01 hertz. And here again, the challenges are to get the right signals and make sense of them that is applicable to your normal operating environment. We have longer cables, which means we need to have smarter measurements. We need to be more sensitive. We need to be able to look deeper into the cable, maybe utilize multi-channel measurements in a new way to get more information from that. And also what we're seeing is that PD measurements are spreading to more industries. Think electromobility, for example. And there is not always a lot of knowledge in those industries about how to do PD measurements, because it is a very specialized topic. One of our challenges is to make PD measurements more accessible to these users. And how do we stay abreast of this? We have people that are involved in standards bodies and in industry groups, so that we are basically right there when these changes are discussed and implemented. We participate in research, and we implement research ideas in demonstrator tools, and then we validate those in the field with our internal customers, with our own measurements, and use that to innovate new features that we put into our products.
You mentioned a bit about gathering research and talking to users about PD measurement and how they respond to features. How does user feedback specifically play a role when developing these new innovations?
User feedback is extremely important to us because we want to have solutions that work for our customers, that solve their problems. And we do this by using a software development approach that is iterative. So we basically develop features in increments and then put them out there to users to test, and then take the feedback and improve on those. And when I say users out there, often those users are internal users within Omicron, but also people outside of the organization. So, for example, our internal application and project engineers, our sales representatives, researchers that we work with in universities and other research institutions, we also go to customers directly and watch them do a measurement or watch them perform one of their common tasks, and then take that information back into the development team to try and design something that makes that process easier. So this is how we work iteratively to improve on our solutions that we have, or even just gain new ideas about how to solve a problem that we might not have fully addressed yet. And one example of this is the guided workflows that I mentioned earlier. For example, the cable factory workflow. The first version of this was actually designed with a cable manufacturer in the field, where we watched them perform PD measurements and then designed a workflow around that.
Given the current testing technology, how much of a PD expert do you need to be able to perform measurements and analyze the collected data?
PD is a complicated topic, that's true. But what we try to do is support all skill levels with our products. I mentioned these workflows. These are one way to address this, by giving users something that is tailored towards their particular use case. And it's more about leaving something out than putting more in. It shows you just the tools that you need for a specific step in your process, and all the other tools that you might not need at that point are not shown. They are available to use if you need them, but they're just not part of the normal process, which makes it more approachable. And I mentioned user profiles, which allow you to customize the user interface of the software itself, which serves a similar purpose. It allows you to leave out things that you don't need and focus on the things that you do need. And as your skill level grows, you can still add all these other tools that are there and give you access to the technology that is there. Another topic that helps with that is the ability to create dataset files, which are basically recorded PD measurements, which you can then later replay and perform analysis on, or maybe give it to somebody who is even more skilled than you and have them do an analysis. We always try to make the tools that we have in the software more accessible by providing help strings, tooltips, have a context-sensitive help, for example, which allows you to just click a button and open the right place in the manual that explains what's happening.
Very good. So clearly these innovations have helped to make it easier for users with less experience to perform PD measurements. You make a measurement and you feel confident about making the measurement because you had a guided workflow to help you if you're a beginner in all of this. But I would assume that another big potential challenge to analyze what the data is telling you. Could you talk about some innovations that have helped make that also very accessible and easy for users?
Yeah. So the analysis is always a little more complicated than just a measurement because the core aspect of that is to focus on the partial discharge phenomenon itself. And the signal that you measure often contains a lot of other stuff that you're not really interested in. Noise, disturbances, other signals, maybe also some electrical discharges outside of the actual test environment. And the core problem is focusing on the things that are really happening inside of your test circuit and identifying those. And we have a bunch of different tools for that. I mentioned a 3-part and 3-frac, which allow you to combine measurements from different channels or at different measurement frequencies to generate a fingerprint of the signal and then use that fingerprint to separate different sources of the signal. And then you can focus on the ones that really are PD and look at those. Another thing that helps with analysis is to look at the signal shape of the actual time signal, not just at the PD event that is detected, but at the signal shape of that. And using our PD event window trigger allows you to do that. You select an area to trigger on a certain PD, and then you see what the shape of that PD event looks like, possibly even on a different measurement channel, where you might not even be able to detect the PD anymore, but you can still use that information from the triggering channel to collect the signal shape at a different place and look at that. And that can tell you something about where does the signal originate, how does it propagate through the acid, how does it get attenuated, what are the frequency components in that signal. And all of these things can tell you something about what type of PD it is and where it originates from. But of course, you still need to know what you're looking for. So there's still a lot to learn about PD, and some knowledge is really useful to perform a meaningful analysis.
Very good. Where can you get some of this knowledge that you talk about to learn more about PD measurement?
Well, Omicron has training classes where you can go to Omicron and learn about PD measurements using the MPD-800 device. You can get in-depth knowledge about what is PD, how does it physically occur, how do you measure it, how do you deal with the practicalities of the PD measurement, how do you resolve problems with connections, how do you detect noise and remove it from the measurements, and all these things.
Very good. So wrapping it up, it is clearly essential to keep up with the trends, revise standards, and present and future user needs. But how do you keep ahead of all of it? For example, with MPD technology, how do you stay 1 or 2 steps ahead of it all?
I think constant contact with customers is really important, which we try to do. We have a very dedicated sales force at Omicron, which is constant contact with our customers. And we also have a very good tech support team. When customers have questions, those questions are collected and also transported into the development teams so that we learn about the problems customers are having. We also have direct contact with researchers and internal colleagues that are involved with standard bodies and industry groups. So I think because we have people that use this technology and are really closely connected to people that use this technology, we really have a good idea about where things are moving and where things are still needed. And as I said, we employ a continuous iterative development approach for the MPD suite, which allows us to address these topics as they pop up. And we have a dedicated product team, which has built up a lot of expertise over the years that allows us to do that. That's the way you stay abreast of things here.
Okay, very good. And software is continuously evolving. It never stops.
Exactly. Yeah.
Burkhard, if you were to meet somebody considering partial discharge testing, what would you recommend to them? Why would it be important for them to start?
The most important reason to do PD testing is because you care about the health of your high voltage asset. You want to know whether your high voltage asset is up to the task and can last for a while longer, or even if it's at a factory test, whether it has the quality you need. PD test will help you answer the question. It will tell you if the insulation in that high voltage asset has discharges that you don't want. So if the insulation is good and healthy. And this helps you if you employ this not just for factory testing, but also over time during the life cycle of your asset. This helps with a condition-based maintenance approach where you only take assets out of operation when you think they need maintenance. And PD testing can help you answer that question. It can help you answer, yes, there's something going on with your asset. Let's do maintenance on it. Or there's nothing here, no PD, things look good. We can operate it a while longer without worrying.
Burkhard, thank you for joining me for this episode of Energy Talks.
Thank you very much for giving me the opportunity to speak about my favorite topic, PD and the MPD.
And a big thank you to our audience for listening to this and other episodes of Energy Talks. We always welcome your questions and feedback. Please send us an email to podcast@omicronenergy.com. Omicron has several years of experience in power system testing, data management, and cybersecurity, and offers a matching solution for your application. For more information, visit our website at omicronenergy.com. Please join us for the next episode of Energy Talks. Goodbye for now, everyone.